Hello, welcome to my channel. In this video, I'll be discussing nuclear chemistry. I'll start with the definition of radioactivity, which is the emission of particles or energy from the nucleus of an unstable atom. The process can be natural or artificial. If you watch my previous videos where I talked about chemical bonding, we concentrate majorly on electron revolving around the nucleus. In nuclear chemistry, we are more concerned about the nucleus itself, which contain the proton and the neutron. We need to know the types of radiations. If you look at the definition of radioactivity itself, it has to do with emission of radiation and or energy. So there are different types of radiations. The first of them we'll be talking about is alpha radiation. And alpha radiation is actually the nucleus of helium as it contains two protons and two neutrons, and it is positively charged. Recall that proton is positively charged while neutron is neutral. You can watch my earlier video on atomic structure. So because alpha radiation is essentially nucleus of helium. It contains two protons and two neutrons, and it is positively charged. If you recall, the mass of an atom is accounted for by both the protons and neutron because electron has negligible mass. So therefore, alpha particles has considerable mass, which is relatively large. And because of its large mass, it doesn't penetrate as much as other radiations that we'll talk about later. And it is highly ionizing. It has ionizing power. And that is the reason is that, you know, electron revolve around the nucleus, right? And we said that this alpha radiation has considerable mass containing proton and neutron. If it if alpha radiation is emitted on an atom, because of its relatively large mass, it can hit electron and knock it out of the atom, thereby making it to become ions. That is why it is said to be ionizing. And the ionizing power is relatively high because of the nature of the alpha radiation, which is due to its large mass. Okay. Beta radiation consists of high-speed electron or positron. Electron, like we know, is negatively charged, but positrons is otherwise known as anti is otherwise known as electron antiparticle. It has the same mass as the electron, but it is positively charged. Okay, so that is positron. For beta plus radiation, it is positively charged, while for beta minus radiation, it is negatively charged. It has higher penetrating power than the alpha radiation. Okay, we said alpha radiation cannot even penetrate a sheet of paper, but beta radiation can actually penetrate a sheet of paper and can only be stopped by few millimeters of aluminum, and it's also ionizing. Okay, although it's not as ionizing as alpha particles, and that can easily be explained by the difference in the mass. The mass of electron when compared to that of pos- the mass of electron when compared to that of proton and neutron is actually very, very small. So, for electron to knock off electron from the shell of an atom, you know, it will not be as effective as alpha particle, which has proton and neutron, which both have considerably large mass. Gamma radiation is actually an electromagnetic waves rather than a particle. It is not a particle, it's electromagnetic waves, otherwise known as photon, and it is neutrally charged. It doesn't have mass, and it has considerable penetrating power. Okay, as it can pass through even an aluminum, can only be stopped by thick lead or several centimeters of concrete. Okay, so it's also ionizing, but it's not as ionizing as alpha and beta radiation. Okay, so if you observe very well, you discover that as the mass of the radiation become negligible, their penetrating power become more. Okay, as the mass of radiations reduce, their ionizing power also reduces. Take note of that. Now, let's talk about nuclear reactions. Nuclear reaction, from the name, is reaction that involve nucleus. The earlier chemical reaction that we talked about, the chemical bonding and the rest, involve the electron revolving around the nucleus. But nuclear reaction itself concerns the nucleus of atom, and it involves change in an atom's nucleus and can result in transformation of elements, meaning that elements can change from one form to another when there is nuclear reaction. And there are different types of nuclear reaction. The first nuclear reaction I'll talk about is nuclear fission. And nuclear fission is a type of nuclear reaction in which the atom of an element with relatively large atomic mass is made to split into two or more atoms of another element. Fission usually occur when neutron is made to interact with nucleus of atoms with heavy nucleus. When this happens, the nucleus of that atom become unstable and is split into two or more different atoms of an entirely different element. And usually in this kind of reaction, neutron can be emitted. And when this neutron too is emitted, it can go ahead to activate another atom of uranium, so leading to chain reaction, the kind of reaction that will continue. That is due to the fact that this reaction generates three neutron, and these three neutron too will go on to activate another atom of uranium, and the reaction continue like that. That's why it can lead to chain reaction. Nuclear fission involve combining of light nuclei to form a heavier nucleus with the release of energy. For example, two isotopes of hydrogen can come together to form one atom of helium with release of neutron and energy. Nuclear fusion most of the times is natural as the condition necessary to induce nuclear fusion artificially is usually very, very difficult. And that is because this kind of reaction requires a very high and sustained temperature and pressure, which may not be obtainable on under a human created conditions. So most of the times this kind of reaction occur in nature, and it is the type of reaction that is thought to occur in the sun, leading to the release of its enormous heat and light energy. The next type of nuclear reaction I'll talk about is alpha decay, and this usually occur when there is emission of an alpha particle from the nucleus. And don't forget that alpha particles is actually helium nucleus. And when helium nucleus is emitted, there is usually reduction in the atomic mass of the atom that is involved, and another atom of another element will be formed in the process. Okay, so there will be emission of alpha radiation. Beta decay usually occur with emission of an electron beta particle from the nucleus, and one electron is emitted, the proton usually increases. That is why with carbon having a proton of 6 change to nitrogen when the proton increase. Okay. The next concept we'll talk about is half-life. Half-life is defined as the time required for half of the atom of a radioactive material in a sample to decay. That is, if the total number of atom in the radioactive material is 100, the number it takes for 50 of the atom to decay. Okay, that is the half-life. And it measures the stability of radioactive isotope. It is half-life of a radioactive material is usually constant, meaning that if it takes 1 minute for half of the atoms of the radioactive material to decay, it will continue to be 1 minute. From the example I gave earlier, if the total number of atoms is 100, in 1 minute it will become 50, and in another 1 minute it will become 25. In another 1 minute it will become 12.5. So the time it takes for half of the atom to decay is 1 minute. It's constant, irrespective of whether the number of atoms is large at 100 or at 12.5. And it's also not affected by physical or chemical conditions. The formula to calculate half-life is given here. Okay, and this N stands for the amount of the atom remaining at time t, while N naught is the initial amount. Okay, the T is the time, while T half is the half-life of the radioactive material. Let's apply this formula in this example. They say if a sample is initially contain 100 grams of radioactive isotope with half-life of 5 years, how much will remain after 15 years? Okay, so in this situation now, the N naught will be 100. The half-life, T half, will be 5 years, while the T, which is the duration, will be 15 years. When we substitute it in this equation, the amount that will remain at time T is equals to the initial amount, which is 100, times 1 over 2 raised to power T, which is 15 divided by half-life, which is 5. 5 here 1, 5 here 3. So this will become 100 times 1 over 2 cube. Okay? And if you evaluate this with your calculator, you will get the answer. When you are dealing with nuclear reaction, like we did in chemical reaction, it is very important for you to balance the nuclear reaction before you do any calculation on it. And there are key rules to follow when you are doing this. It still applies to the the principle of conservation of mass still applies in that we use the principle of conservation of mass that we use in chemical reaction still applies in nuclear reaction. And another thing that you need to take note of is that the atomic number of all the entities in the reactant should be equals to the atomic number of all the entities in the product. So if you have atom X that decay, maybe alpha that undergo alpha decay to give another atom Y, okay, with emission of energy. Let's say the atomic mass of this is A and the atomic number is B. The atomic mass of this, let's say, is C and the atomic number is D. The total number of this A plus 4 must be equals to C, and the total number of B plus 2 must be equals to D. So, on both sides, the atomic mass and the atomic number must be equal. The steps to follow when you are balancing a nuclear reaction are this. Number one is you need to write down the given reaction. You check the sum of the mass on both sides, ensure that it is equal, and check the sum of the atomic number on both sides and ensure that it's equal. If an unknown particle or element is missing, you use the periodic table to identify it. And also, you use this table to identify which of the particles is emitted. Take note of this table as we'll be using it in the next challenge to balance nuclear reaction. I'll start with an example. Let's say a uranium 238 with atomic number 92 undergo an alpha decay to give an atom with atomic mass A and atomic number Z. Let's say it undergoes an alpha decay, emitting the nucleus of helium. If you are asked to find the missing number in this example, if you are asked to find the element that is produced when this uranium undergo this alpha decay. What you are going to do is this. From the earlier steps that we talked about, first of all, we need to write down the equation which we have done. Number two, the next thing to do is to check the atomic mass on both sides. And I said the mass number on both sides of the equation must be equal, meaning that 238, which is the mass, must be equals to A plus 4. Okay, so if we look at this equation now, A will be equals to 234. Okay, now we've gotten the atomic mass. Now, what will be this Z? We said the atomic number on both sides too must be equal, meaning that 92 must be equals to Z plus 2. So Z will be equals to 90. So having gotten the mass and the atomic number of this atom, it means that this atom will be something like this: an atom X that has atomic mass of 234 and atomic number of 90. So we can now look at our periodic table and look at an element that has atomic number of 90 and atomic mass of 234. So that will be the element that is produced when uranium-238 undergo an alpha decay. Okay, so this is example 1. Let's see another example. Let's say a carbon 14 undergo a beta decay and produce another atom with this parameter, atomic mass of A and atomic number of Z, emitting electron. Now, if we are asked to find out what element is produced, meaning that we are asked to find this element, we need to know the atomic number of the element and the atomic mass. How do we know that? Still the same principle that we did here. 14 must be equals to A plus 0. Therefore, A will be equals to what? 14. Now, for the atomic mass, 6 should be equals to Z minus 1, right? So this is, let me break it down, plus minus 1. And we know this is the same thing as Z minus 1, right? So we know that Z will be equals to 7. Okay, so meaning that this atom will be an atom that has an atomic mass of 14 and atomic number of 7, which is what? This is nitrogen. You can check your periodic table. Very likely it will be nitrogen. Okay, so let's look at the final example in which sodium undergoes a beta decay, producing an element with this parameter. I believe you should be able to do this yourself, the same principle that we used here. Okay, try it and you can comment your answer in the section below, which element it is. So this is how you will be balancing nuclear reaction. Okay, and you can also find out which element is produced in a nuclear reaction. Just recall that if it is an alpha decay, it will be nucleus of helium. If it's a beta decay, it will be emission of electron, except otherwise specified. If it's a beta decay, it's electron, except if they specify that it is positron. And if it is positron, you know it will be E with atomic mass of 0 and the charge of +1. Okay, so alpha decay, beta decay is how you'll be doing that. Now, let's look at the uses and application of radioactivity. Radioactivity has a wide range of applications in medicine. It is used in diagnosis and it can also be used in carbon dating. If you want to know the age of an ancient artifact, you especially for the archaeologists, you can use carbon 14. Okay, and also artificial radioactivity is used in nuclear power to make to generate electricity and also in treatment of cancer. Having gone through the let's look at some questions to test our knowledge and understanding and also to reinforce some of the things that we have learned. Question number one: what is the difference between a chemical reaction and a nuclear reaction? A chemical reaction involves nucleus. Nuclear reaction involve electron. This is not correct. It is the other way around. Chemical reaction involve electron, while nuclear reaction involve nucleus. Chemical reaction involve proton. Nuclear reaction involves the nucleus. That is not correct. Chemical reaction involve electron. Okay, while nuclear reaction involve nucleus. So this is not correct. Chemical reaction release more energy than nuclear reaction. That is not correct. Nuclear reaction release enormous energy that is far much more than the chemical reaction. Okay, it's not correct. Chemical reaction cannot change elements while nuclear reaction can. That is correct, as we have seen in earlier examples where uranium undergo decay to produce another element. Next question: which particle is emitted during beta decay? Proton? That is not correct. Neutron? That is not correct. Electron? That is correct. Okay, and proton is not the particle emitted in beta decay. Neutron is emitted when there is nuclear fission. Nuclear fission. While electron is emitted when there is beta decay. Okay, and alpha particle is emitted when there is alpha decay. So the correct answer is C. Which of the following is a common use of radioisotope in medicine? Treating bacterial infection? That is not correct. You rather use drug to treat infections. Measuring blood pressure? That is not correct. Imaging internal organs? That is correct. Controlling pests? Radioisotopes, radiations can be used in controlling pests in agriculture actually, but not in medicine. So the correct answer is C. What type of radiation has the greatest penetrating power? Alpha? That is not correct. Beta? That is not correct. Gamma? That is correct. Neutron radiation? That is not correct. You can check my earlier slides. You can wind back for you to see where I explained this, all the different types of radiations. Okay. What is the half-life of a radioactive isotope? I think I discussed this earlier. Go through it and comment your answer in the section below. Which of the following elements undergoes natural radioactive decay? hydrogen, carbon, uranium, oxygen? I think you should be able to answer this. You can write your answer in the comment section. In which type of nuclear reaction is a neutron absorbed by a nucleus? I mentioned this. Fission, nuclear fission occur when the neutron interacts with the nucleus of an atom. Okay, so it's actually in nuclear fission. If you disagree with that, you can comment in the section below. What happens to the atomic number of an element during alpha decay? In alpha decay, what is released? We know in alpha decay, what is released is actually helium nucleus, which has two protons and two neutrons. Okay, so you should be able to answer this with this. You can comment your answer in the section below. If you don't understand, just comment in the section below so that I can explain better. If you want me to make another video to explain it, comment in the section. Okay. Which process powers the sun? Which process powers the sun? I mentioned this in the earlier slide. Which of the following is a product of nuclear fission in stars? You know, in the sun and the stars, the fission is the driving force for their enormous energy that they release, both heat and lights. And the fusion that occur is actually between hydrogen atoms. And when they fuse, they form helium. Okay. So what is emitted during the beta plus decay? In beta minus, what is emitted is electron, while in beta plus, what is emitted is positron. Okay, you know electron is emitted in beta minus, proton is not emitted, neutron is can be emitted in fission, in nuclear fission. Okay, in beta plus decay, positron is emitted. The correct answer is positron. What happens during a nuclear chain reaction? In nuclear chain reaction, one nucleus splits and the reaction stops. The reaction doesn't stop in chain reaction. One nucleus splits releasing energy but no further reaction. That is not correct. The reaction continues in chain reaction. One nucleus splits releasing neutrons that induce further fissions. That is correct, as we saw in fission of the uranium, when neutron is made to interact with the nucleus of uranium and the uranium splits into another atom and release more neutron to cause chain reaction, which I mentioned earlier in the slide. So the correct answer is C. One nucleus splits forming new chemical bonds. That is not correct. Which isotope is commonly used in carbon dating? I mentioned that in the earlier slides. How does gamma radiation differ from alpha and beta radiation? I talked extensively about this while discussing the different types of radiation. You can write your answer in the comment section below. If you are still confused, let me know so that I can explain better. Thank you for listening. Please, but before you leave, if you like this video, if you enjoy this video, click like button, subscribe to my channel, and when you subscribed, click the alert bell for you to be notified when I make new videos, and share with your friends for them to benefit. Till I see you in my next video, take care and bye bye.